Let's quickly talk about the DirectSoft6 D4-454. Right off the bat, this thing is so old that if you try to Google it, you'll get a dice on Google. I know that you will be frustrated with this, and I know that you'll want to take liquid crack. The manual for this has computer images from Windows 98. Anyway, without further ado, let's get into what I have here so we can see what's going on. So for this program, I will be using VT-SCADA, and that's going to be on a thin client on that monitor on the door. So you will need a screwdriver in order to take a look at the back of these cards, which you will need to do. You will need to see the back of these cards. Loosen up the screws at the very top. The screws will not come all the way out, which is fine. Then you can kind of pop and lean back, these cards and take a look inside of them. The CPU one doesn't have anything in the back that you need to touch. The Ethernet one, I would recommend not touching these dip switches. In these modern times, you typically know what the IP address is that you want to put into these things. I can't remember exactly why you would even need to touch those. Just don't touch those. Let's go ahead and take a look at the digital inputs. This is 2 8 points, so 16 point, I guess. There's nothing in the back that you need to touch, so we're going to put the bottom in first and then lean it back, and it will just kind of click in place. The digital output, we're going to pop that one out. There's nothing in the back, so we're going to put the bottom back in and then lean the top into place. The analog cards are going to be a B. All right, so the back, if you're lucky, it comes from the factory with these pieces, plastic pieces in the correct place. You will need to see the manual. I'm legitimately not kidding when I say these manuals have not been updated since '98. Here's the latest from their own website. In the process of reading the manual, you'll see exactly how I got 4 to 20 milliamps. Basically, from the top image, you can see that's the 4 to 20 milliamp. And then directly under it, you can see that it's already 4 to 20 milliamps. And since I'm using 8 channels, you can see that the pins suggest that I'm already using 8 channels. So I didn't have to touch anything, thankfully. Now that I verified it came from the factory, 4 to 20 milliamps, I didn't need to touch anything and I could put it back. Now the analog output card also has like a single jumper on the back of it, which comes from the factory exactly the way I needed it. So I need to put that one back as well. It actually appears I didn't loosen it enough, so we're just gonna skip it entirely. You get what I'm saying. Now we're gonna grab our handy dandy screwdriver and we're just gonna tighten them all back where they need to be. Now I know you came here for a YouTube video, but I'm gonna have to refer to the stupid manual again. You will need to make sure you wire this right, otherwise you will get an error in the PLC. The bottom 2 nuts do need individual power. Now you can technically power it from the CPU itself. If you look on the left side under a plate, it does have 24-volt power supply capabilities, but I just straight gave it its own individual wire and fuse and circuit breaker and whatnot, and wired it up to those analog input and analog output cards. If you have a loop analog, you will need to wire it correctly and make sure that it's looped correctly. It being labeled channel 7 and channel 8 is just for the image diagram itself. It doesn't mean that it has to be channel 7 or channel 8. It could be whatever fucking channel you need. So the very front of this has a button, and it goes to run, basically program and then stop. If you put it into run mode, you will not be able to program it at all. I basically just leave it dead center, right in the middle. And those lights will come on, and that's handy dandy. But this is the exact model that I'm using, so just showing you there. Now I will go over the nitty-gritty details of DirectSoft itself. Oh, man, that was a pain in the butt to work with. But I'm going to go ahead and explain what's all going into this PLC to begin with. Let's look up at the very top right here. Naturally, you got surge protection. We got terminals to hold all the power. We have a circuit breaker. We have more circuit breakers. This one's specifically for the PLC. We have relays, which that's literally holding the light on and light off. We got a bunch more terminals, a bunch of circuit breakers. So we got the top, which is all common, and then we have all the digital inputs, common, and then digital inputs. And in total, we have like a lot of digital inputs. I think like 32 digital inputs. I'm not sure, just a whole bunch. This is the Ethernet. It's a managed switch. And then we have more terminals, more circuit breakers, and then we have a butt ton of analog transmitters. All the way up to here is inputs, and then the last 4 are going to be outputs. And I actually marked them with a little dot so I could keep track, because it's a lot. And then we have a whole bunch of relays because we have a whole bunch of things happening, and then more terminals. And this also has where VT SCADA is going to be, and you could plug a mouse and keyboard right there if you really need to, but it is technically touchscreen, and it's also really expensive, so you don't want to drop it or slam it against anything. We'll also be receiving fiber, and whatever you do, don't stick your finger back in there behind the light, because it is exposed wire and you will be electrocuted, and it doesn't feel great. I'm going to remind you that this is a very frustrating software, and I know this is going to be a learning curve even for experienced programmers and engineers. Let's go ahead and get some preliminary stuff out of the way. All inputs will begin with an X as the address. All outputs will begin with a Y as its address. We'll talk about it later, but they will end up storing their information into a V register instead of an X or a Y. So the X and Y is strictly just to stick information in there for a brief second. You can see the very first card says 8 input, and it says 0 to 7. And that's true. It starts with 0 and it ends with 7, and that's 8 points. It will skip X8 and it will skip X9, and it will do that everywhere, like literally everywhere. It'll skip 27 and 28. It'll skip all of the 80s and all of the, hell, it will skip X800 all the way. My bad. It will skip X700 and 78 all the way to X999. You can't touch any one of those. You literally cannot touch any one of those. It is completely blocked by the program. Now the second card says 16-point input, which is correct. It has 2 18-point inputs built into one card. And you can see that because it goes X10 to X27. And obviously if you skip X18 and X19, as well as X28 and X29, you will find out that that is 2 8-point inputs, which is a total of 16-point inputs. We'll find out later that that's actually not a legal spot for that card, but that's just the basics, of how you get that far. Now, you can actually put an output card in between the first and second card, and it'll still be the same because X's only know X's and Y's only know Y's. So it'll still be the first card with X0, and the second input card will still be X10, even though it's the third card. You'll understand when you're testing the panel. Anyway, stepping back a bit, if you add the first card and the second card together, how many points will you get? You'll get 24 points, and that is more than 16. So each group of 16 have to be separated. So right now we have 24, and that's just not possible. You can't store that information, so you'll get an error. So here's the correct format. Make sure you have the right card, basically. So you can see the first 2 cards are both 8-point cards, and that equals 16. You could also use just a 16-point card at the very front, but in this image, they didn't. They have 2 8-points, and then they have a 16-point, and then another 16-point, and another, and another. And it's just how the memory works. Speaking of memories, this PLC gave me the worst memories. Anyway, let's actually look at the V registers. So you can see at the bottom, the big blue bar right above it, it says V4-454, and then it has a line, and it's pointed at that 16-point card because that is the V register for that 16 group of bits, basically. And at the very bottom of the blue bar, you can actually see that it goes from X20 to X37, and it skips X28 and X29. So that is like the most visual way you can see that V register. So that V register holds all the information for that entire card. So stepping back again, if you try to get one card to split information between 2 V registers, it just straight would not work. So that's why it's crucial that you make sure that you're grouping it by 16s perfectly. So in the manual, it actually says that there are 32-bit cards, I would advise against that. Even though you're saving space, it's going to be crowded as heck. And you would have to deal even more with, you know, I don't know how it works. I would assume that it would mean that 2 V registers are tied to 1 card. I guess that could work, but I would just find it a headache. I would just stick to either 8 points or 16 points. Fun fact, at the bottom left of your screen, you're actually able to put a data viewer there and type in what V register or X register or Y register, wow, I said that ridiculously, and see what the actual status is, assuming that you enabled show status, or I don't know what the frick the button's called, but show status and you see the status. Doing it for an X, like X40, is great. You'll be able to see if it's off or on. I don't know why it shows 30 there. You will not be able to see V register D4-454 or whatever. You will not be able to see that because that register is holding 16 wires of information inside of it, and so it's just going to be sporadic as all hell could be. We will talk about how to visualize the inputs and outputs of an analog in a second, but we'll start with something a lot easier, like seeing the X and where to put it. This part's basic. You just create like a normally open rung for X0, and then it goes into like C0. And you will always use C as like the internal bit, just for programming. It'll always start with this C, and you'll put a number to it. And then you could, in the description, you can put what it is, like it's X0, whatever X0 is, whatever input that is, you just label it that. And then for Y0, so in this instance, C0 is immediately being turned on when X0 is turned on. And then that sends Y0, which obviously is a physical wire, whatever that's outputting to. Before we get too far into this video is sponsored by... I don't have a sponsor, and I'm on the toilet. Hold on, give me a second. I need to fix myself. Also, one quick thing I'd like to add is this rebrand on the Cherry, I don't really like it, but I've noticed that this version, for some reason, goes flat extremely fast, and it makes it taste different. So I don't know if it's because it is somewhat different, even though the ingredients are exactly the same to the original box. But it definitely tastes different, and I think it's just because it goes flat like 20 times faster than normal. Wait, Mitt, stop. You're already talking about the program and you didn't tell us how to configure the IP address. Well, first of all, you're going to have to download NetEdit 3, which is a very old program. All right, and then let's jump into it. We're going to use TCP IP, so I'm going to click that box instead of IPX. I'm also going to assume that you already know what IP address you want to use, and you already know how to change your computer to be able to read those IP address ranges, because that's pretty basic. Anyway, to connect to this piece of crap, it's not going to have an IP address at all. You will need to know its MAC address, which you can find if you pop that sucker off and look at the stickers stuck on the back of it, the most inconvenient place possible. It will start with like 00, E0, 62, maybe 40, and then it'll have like a couple more numbers after it, and you'll need to put that in order to be able to set an IP address to it. I don't have the software right in front of me, so I can't go specifically step by step on how to do it, but your model ID will be 0 for sure. You will need to give it a name. You do not have to give it a description, and then you'll want to click use the following IP address and, well, put your IP address in there that you want it to use. Anyway, back to the programming. So now you want to know how to read analog inputs, and oh man, it is a doozy. I was not even able to get iBoxes to work for the top of the line PLC that they have, which is absolutely ridiculous. iBox is like their latest programming ingenuity, which is garbage. Anyway, so this is how you will do it. The manual has many ways to do it, but you have to do it this way. I cannot help you if you do not do it this way. All right, let's just put it that way. SP1 means that it is just always on. You will need that in order to power the rung. You can't, I don't know why you need it, okay? And if you use SP0, that means it will only power on when the PLC initializes, which is, I guess, good for resetting values, which let's say you have a output turned on and then you wipe the PLC. Well, guess what? You may have wiped it, but that output is still on because you never told it to turn off. This program or this PLC is so old, it doesn't even correctly wipe its memory. Anyway, so that's an instance where you'd use SP0 to make sure everything is off when you initialize. Anyway, let me explain what we're looking at here. So we got SP1, which means it's always on. And then we had LEF, which just means load. In this case, it's going to load the first 12 bits, which in reality is going to be like 16. But so it says load X20. So X20 is going to be their very first analog input. In my case, it was X40. So I put X40. And then it says K12. K just means just a number. It just means a number, a constant. In this case, they wanted to use K12, which you will need to use as well. So in our case, it was load X40 K12. All right, so that's the very first box. Oh, you know what I really hate about this software is you have to hold control and arrows in order to build rung pieces. That is ridiculous. All right, it should just automatically generate rungs for me. So in this case, if you want to make that BCD thing, you have to click the load, and then you have to hold control and push the down arrow, and then type BCD and click enter. And it'll create that, which all it does is convert the analog input readings into binary decimal hex, whatever it is. And then you'll need to do it again, the control down, and create the LDF, which is going to have X34 and K3. Now, if you use X40, for example, that X34 needs to be X54. So it will always be 14 numbers higher than your first input. So, or whatever your input is at that box at the top. So, 20 plus 14 is 34. 40 plus 14 is 54. So I'll use X54. And you will still need to use whatever K value it tells you to use. In this case, it's K3. So we will put K3. Now it wants you to create another box, and that's going to be where all that information is being outputted to. And you will want to do that. You will have to do that, actually, because if you don't, you won't be able to read any of that information. So it's using OutX, which you'll want to type and click enter. And then you're going to put a V register in. So they use V3000. I did whatever I wanted to, and I chose V2040. And I used 40 because I just wanted to remember that it was X40 because that was the one I chose for my analog input. And then I just started with 2000 because I felt like using 2000 and it hadn't been used yet. So I used V2040. You will only have to make that one rung for the next 8 channels, so 0 to 7, because it's loading all 8 channels at once. All right, so you will not need to make an X21 or an X41. It's all there. It's just compacted in there. Now you may be a little confused because you're like, well, Mitt, there's V3000, right? But earlier in the manual, it said to use V40402. Well, technically, that is a V register that it's in. You could just completely ignore that. That information is being stored in that V register, which if you typed it in the data viewer, it would come up like VX40. It's just the nickname for like V40,401 or something. Just ignore all that information. It's not really all that useful. All right. So if you're going to use V3000, use it. All right. I used V2040 and that's good enough for me. And I put in the data viewer V2040. Now that's not where all the good information is being held. So don't put that into VT SCADA. expecting to see results, because you'll get all 8 channels at once. So let's go to the next part. So we're going to review this again. So the very first part, SP1, it says I'm going to load X20. In my case, it was X40. And then I'm going to convert that to binary. And then I'm going to load the next 4 pieces, which are located at the 14th place after X20. And then I'm going to output all that information into outX, which is V3000 in this case. All right, so to doing all that, you don't really need to know why. All you need to know is what your very first X20 equivalent is, and then add 14 and put that in the other load box. All right, that's all you need to know. They used K4 in this instance, so it's possible that you will need to use K4. I am aware that in the previous picture we used K3, but this one used K4, and I'm pretty sure I did my own program based off this picture, so I would suggest switching that K3 to a K4. I don't know why they did it. This is a piece of crap software. I'm sorry. I don't know what to tell you. All right, change it to a K4. Now we're going to talk about the X1 and why we need that section. Right off the bat, it's trying to cause more confusion. It says use X1. You do not need to use X1, all right? That means X1 that would be your second input. I don't know why it's telling you to do that. You can just use another SP1. It'll be totally fine. There is no problem with that. Use an SP1, all right? And then it says LD, which means load, V3000. So it wants you to load the very first register. All right, so that would be the very first analog input, which ironically is holding all the information from all 8 channels. All right, but just trust me on this. All right, that is going to be, in some weird way, that is going to be the information for your first analog input. Then it's going to multiply it by 1,000. I actually multiplied it by 100 because I wanted the result to be between 0 and 100 because I was using speed, VFD speed. And then you can divide it by 4095 because that is just the highest number that you can even use in. It's just the way things work out, all right? Just divide by 4095. I don't have time to explain why. And then you're going to output it to V3100. Now, that can be anything you want. In my case, remember, I did V2040 for my load. And then for the output, I actually used 2140. Now, what you just did was you made that V3100 only read the very first analog input. All right. I don't know why or how this really works the way it does, but in that sense, it perfectly reads the analog input. So if you go to your data viewer and you type 3100, you will only see the results for the first channel of the analog input, which is exactly what you want. So now you want to see the second analog input, the second channel. So that X1 area, you're going to basically duplicate that rung that you just created. So it'll be another SP1, and then you'll load V3001 or whatever your equivalent is for the second channel. Then you're going to multiply it by 1,000, or in my case 100, and then you're going to divide it by 4095, and then your output will be the next number. So in this instance, it'd be V3101, or in my case, it would be V2141. Now, in case you're wondering why the analog input starts with X20, or in my case, X40, it's because the digital inputs took all the space before that. So I had 37 digital inputs, you know what I mean. I had all that information filled up with digital inputs, and then analog inputs started at X40. So it'll essentially look like this over and over and over again. So the specific analog output that I'm using this time, it only does 4 to 20 milliamps. Now there is the second version of that exact card, and it'll do all the other versions, and it'll have a bunch of different jumpers in the back, and you'll have to read the manual on which jumpers need to be there. And it could be correct by default. But for my instance, it was just 4 to 20 milliamps, so that's what I'm using for the manual. Exact same rules. You can't split 16-point card in between two V registers. You will have to either figure that out, like have 16-bit before it, or an 8-bit split. You'll have to figure it out. You can't confuse two V registers together with a single card. Well, I was gonna try to show you guys my code for analog outputs, but I've never had this happen before. It just straight up won't even tell me the names of anything. Like I can't see anything right now.